On a TCP/IP network, computers use IP addresses to specify which host data should be sent to. The problem is that end users aren't usually comfortable using IP addresses. For example, it's easy for most people to remember the name of a website like testout.com, but I doubt many people could tell you what its IP address is. The domain name system, or DNS, is the system that IP networks use to convert a host name into an IP address. For example, when you use an internet browser to access Microsoft.com, the computer uses DNS to look up the IP address for that name. In this lesson, we'll talk about how DNS works. We'll look at the DNS structure, the name resolution process, and the recursion process. We'll also look at the host file's role. We'll review how DDNS works and the record types a DNS server stores. DNS is a hierarchical naming system. We call it hierarchical because it looks like an upside-down tree. At the top of the tree is the root, which is represented by a period. Below the root are the top-level domains, which encompass such domains as .com, .edu, .gov, and so on. Below each top-level domain are additional domains that are typically assigned to different organizations. For example, you might have a domain for Microsoft, another for my company, and so on. The DNS namespace is referred to as distributed because this portion of the namespace is delegated to different organizations. Microsoft is in charge of maintaining the namespace for its organization. My company would be responsible for all of the names within its company. You can also define additional subdomains within each domain, such as sales or accounting. At the end of the hierarchy are the actual host names that represent specific hosts. For instance, you may have servers in your organization named Server 1, Server 2, and www. You may not have realized it, but the name www is actually the name of a computer. It's a host name. When you refer to a specific computer, you start with the host name and then work your way back up the hierarchy to the root. This is called the fully qualified domain name, or FQDN. For example, the fully qualified domain name of the host named www would be www.sales.mycompany.com. Notice that each domain is separated from the host and other domains with a period. The FQDN also includes the name of the root, which is just another period. The trailing period is usually omitted, but technically it is there. The FQDN of a host starts with the host portion of the name, followed by each domain up the tree to the root. Another concept you need to be familiar with is a DNS zone. A zone is an area of the namespace under the administrative control of one server or that resides on a single DNS server. DNS servers maintain a part of the namespace. At every level, there are servers that maintain a specific portion of the namespace. In this case, my company may have a single DNS server, and the My Company namespace would be encompassed in a single zone. You could add another server at a later time that stores information about just the sales subdomain. In this situation, there would be a zone here and a zone that includes the rest of the namespace. At the top of the hierarchy are the root DNS servers. Root servers are servers on the internet that keep track of everything within the root domain. This includes the IP address of the servers at various levels. Within the .com domain, there are servers that maintain information about subdomains within that domain. Microsoft has set up its own DNS servers to maintain information about hosts within the Microsoft domain. The term zone refers to the actual database that resides on a DNS server. The term domain identifies a division within the DNS namespace. A zone could encompass multiple domains, or it might include only one domain. Let's look at how name resolution works. When you use a logical host name to address a message to a destination computer, your computer needs to convert that name into an IP address before it can send the message. It does this using a DNS lookup process. For example, you need to access www.comptia.org in a web browser. Your computer needs to resolve www.comptia.org into an IP address. First, the computer looks in its own local hosts file for an IP address mapping www.comptia.org. The hosts file is a text file on your computer that maps host names to IP addresses. The hosts file was originally used for name resolution in the early days of IP networking, but today they're only minimally used because they're hard to keep updated. It would be very difficult to maintain a text file that includes host name to IP address mappings for every server on the internet. The hosts file still exists on all modern operating systems, and your computer will still consult it first to resolve a host name into an IP address. If the computer can't find a mapping for the host name in the hosts file, it'll submit the host name to a DNS server for resolution. This DNS server might be on your private network. It might be an external DNS server at your ISP or in the cloud somewhere, or it might be a publicly accessible DNS server on the internet. When you configure IP networking on your computer, you usually configure it with the IP address of a DNS server that it should use for resolving host names. In this case, the computer asks the DNS server for the IP address for www.comptia.org. At this point, the name resolution process can get complex. First, the DNS server looks within all of its own zones for the requested host name. If the DNS server has a local zone configured with name resolution information within it, it is said to be authoritative for that zone. In other words, it doesn't have to ask any other DNS server for help because it already has an IP address mapping for the host name being resolved. In this example, the DNS server will look for www.comptia.org within its own database. If the server finds that address, it responds directly to your computer with the appropriate IP address for that host. If the computer doesn't find that address, then the server needs to get help from another DNS server using a process called recursion. The first thing the DNS server does during the recursion process is contact a root domain server on the internet and ask that server for the IP address of a top-level domain DNS server, in this case, the .org domain. All DNS servers are configured with the IP addresses of the root domain servers. They don't know the IP address of any other DNS servers on the internet. The DNS server submits this request to the root server and asks for the IP address of the .org DNS server. The root server looks in its database and returns the IP address of a DNS server that stores information for the .org domain. Let's say it's 1.1.1.1 in this case. At this point, the DNS server submits another request to the .org DNS server that it was referring to, asking for the IP address of a DNS server that is authoritative for the comptia.org zone. The .org DNS server looks in its database and it returns an IP address for a DNS server for comptia.org. Let's say it's 2.2.2.2. Finally, the DNS server submits another request to the DNS server that's authoritative for the CompTIA zone and asks it for the IP address of the host named www. The CompTIA DNS server responds with the answer, let's say 3.3.3.3. At this point, your computer finally has the appropriate IP address and can contact the server named www@comptia.org. This is how the recursion process works. After recursion, your DNS server keeps a copy of the mapping for www.comptia.org in its local cache. This eliminates the need to go through the whole recursion process again the next time another client asks it to resolve the same host name. The local computer that initially made the request also puts the IP address in its own name resolution cache. The next time you open a browser and try to access the same website, the computer can look in its own local cache to get the appropriate IP address mapping without asking the DNS server to resolve it. The cache is typically only valid as long as the computer remains running, so if you shut it down, the cache is flushed. The entries in the local DNS cache probably have an expiration date. If your computer is left on for several days, the entries in the cache will be gradually removed as each one expires. DNS servers can also be configured to submit name resolution requests directly to another DNS server. This is called a caching-only DNS server. A caching-only DNS server doesn't contain zone information or a zone database file. Instead, its job is to build up an extensive name resolution cache that can be used to resolve host names for a client. You might do this, for example, if you have a DNS server on your private network, but you want the DNS servers on your ISP's network to do all of the recursion work. In this case, when your workstation submits a request to the caching-only DNS server, it forwards that request directly to another DNS server, and then this DNS server uses the recursion process to resolve the name. The address is cached by your DNS server and then returned back to your workstation. DNS servers can be configured with IP address mappings for internal network hosts. This allows computers to resolve internal host names and map them to IP addresses. Typically, DNS servers are populated with mappings for network infrastructure devices, such as servers and routers. However, mappings for workstations can also be added. Most workstations use addresses that have been dynamically assigned by a DHCP server. Manually maintaining DNS records for DHCP clients would require a ton of administrative overhead. To make things easier, most DHCP and DNS servers support a feature called Dynamic DNS, or DDNS. Using DDNS, the DHCP server sends an update to the DNS server whenever it assigns an address to a DHCP client. The DNS server then automatically creates the appropriate mapping that can be used for name resolution. When the DHCP lease is released or expires, then the mapping is automatically removed from the DNS server. There are a couple of additional DNS-related concepts you should be familiar with. The process of resolving a host name to an IP address is called a forward lookup. It takes a known host name and returns an IP address. You can also perform a reverse lookup by giving an IP address to the DNS server and asking it to return the corresponding host name. On the DNS server, IP address mappings are contained in records. An A record maps an IPv4 32-bit DNS hostname to an IP address. This is the most common resource record type. An AAA record, also called a quad A record, maps an IPv6 or 128-bit DNS hostname to an IP address. A PTR record maps an IP address to a hostname, and this way it points to an A record. An MX record identifies servers that can be used to deliver email. A CNAME record provides alternate names or aliases to hosts that already have a host record. Using a single A record with multiple CNAME records means that when the IP address changes, only the one A record needs to be modified. An SRV record is used to locate a particular host that provides a particular service. SRV records are created automatically by Windows as needed. An NS record identifies DNS servers, or the zone. There is one NS record in the zone for each DNS server that has a copy of that zone. SPF and DKIM records are quick methods for improving your email delivery rates. With this addition to your DNS entries, you're telling recipients that you've authorized a third party to send emails on your behalf. That's it for this lesson. In this lesson, we reviewed how DNS works. First, we looked at the hierarchical DNS structure and the name resolution process. We looked at the role of the hosts file and explained the recursion process. We also discussed how a caching-only name server works. We briefly reviewed how DDNS works. Then we ended this lesson by discussing several DNS records stored by a DNS server.